Hello test takers and welcome back to Exam Prep Solutions, and today we have a surveying style question, although this could fall under maybe construction or even mathematics, so quite a few applications here for this kind of problem. But let's read the description. Utilizing the method of area by coordinates, find the area of the figure seen below in feet squared. So we have a coordinate plane here. We need to use this method of area by coordinates. And how exactly do we do that? So we can see we have quite a few distinct shapes here, so it's tough to determine, okay, how do we find the area of this distinct shape? And the first thing we need to do is divide these up into different kinds of shapes, find the areas of that, and we use that by finding them on the coordinate plane and doing a bit of eye guessing where these shapes begin and end on the coordinate plane and using that to determine how to find the areas of these different shapes. I'll explain here. So we're going to need to cut this up in a few different areas. I'm going to conclude that area 1 is this rectangle here, okay? It's pretty clear that we've got a rectangular shape. Let's find the area of that first. So we can see here on the coordinate plane for the x-axis, it begins at 1.5 and goes all the way to 7. So we know that this is about 5.5 feet in length. And then we would multiply that by the height. And on the y-axis here, it's got a height of 3. So we put 3 in there. Area 1 is equal to 16.5. And if we kind of eyeball this here, okay, we've got 3 to 6, and we multiply that by 5.5. We can definitely see that it would be 16.5 square feet. Now for the next area, we're going to go with this semicircle here. And for the purposes of this problem, I'm going to assume this is the entire semicircle. I know it doesn't completely cover each part of it, but we're just going to go with it for our estimate here. So we can see this is a half circle. We know the equation for the area of a circle is pi r squared. The difference is now it's going to be pi r squared over 2. So what is likely the radius of this circle? Well, it looks like it's going to be about 1. And so if we have pi, which I'm going to use 3.14159 times r, which is squared, right? Pi r squared, but we're going to divide it by 2. So that equals 1.5708, which I'll just put 1.57 for our cases there. So that was area 2. I'm going to assume that this is basically a rectangle as well. It's got a height of 1 and it's got a length of about 3. I'm going to consider that to be area 3. So 1 times 3, pretty simple, 3 feet squared. Then for the last shape here, for area 4, this appears to be a triangle. And we know the equation for the area of a triangle is 1/2 base times height. The base here appears to be 3. The height appears to be, looks to be about 2.5 in this case. So if we go 3 times 2.5, times 0.5, we can get 3.75, and now we need to total all these areas together here. So 16.5 plus 1.5708, I guess, just for accuracy's sake. And then we have 3, and then plus 3.75. And now we get 24.828, so it looks like the answer is B in this case. So when you have an area by coordinates problem like this, identify which axes it's going to be with relation to, divide it up into shapes where it's easy to find the area, right? Don't try to find the area of this entire shape because it's not exactly a half circle, okay? Divide it up into smaller, easy to solve areas and then total them together. And that's really the methodology for this kind of problem. So if you have any questions about that or any questions you'd like shown on the channel, just leave a comment down below. And anyways, we'll see you guys next time.